Reflection of sound waves. Like light, sound waves gets reflected when it strikes a hard surface. We know that light waves get reflected back by a mirror. Here, no smooth surface like a mirror is needed, only a hard object is needed like a metal sheet or a wall. So, sound wave gets reflected back. The return of sound wave on striking a surface such as wall, metal sheet, etc. back to the same medium is called reflection of sound wave. The condition for reflection of sound wave is that the size of the reflecting surface must be bigger than the wavelength of sound wave. The size of the reflecting surface must be bigger than the wavelength of sound wave. Next is echo. If a person stands a distance from a wall or a hill and produce sharp sound, he can hear two distinct sounds. First one is his original sound that he has produced. It can be heard instantly. The second sound is the sound that comes after reflection from the wall. This is called echo. Let us try to define echo. The sound heard after reflection from a distant obstacle after the original sound has ceased is called an echo. The sound heard after reflection from a distant obstacle after the original sound has ceased is called echo. The original sound will stop after some time. After that, we can hear the echo. Echo is heard only if the distance of the person producing sound from the obstacle is far enough to allow the reflected sound to reach the person at least 0.1 second after the original sound is heard. So, after the original sound is produced, the reflected sound must reach at least 0.1 second after to hear an echo. So, let us try to find the minimum distance for which we can hear an echo. Here we have a person standing here. A wall is seen here at a distance d from him. Let v be the velocity of sound in air and d the distance between the person and the obstacle. We have time is equal to total distance by speed of sound. Here the sound wave travels from the person who produces the sound, gets reflected back and comes back to the person. Here the total distance traveled by the sound wave is, this is d and this is another d, that is 2d. For total distance we can write 2d and velocity of sound is 340 meter per second. Here we know that the time must be at least 0.1 second. So 0.1 is equal to 2d by 340. So on calculation we get d is equal to 17 meter. So to hear an echo distinctly, the distance between reflecting surface and the listener must be at least 17 meter. This is the case when sound travels in air. So to hear an echo distinctly, the distance between reflecting surface and listener must be at least, the minimum distance must be 17 meter. This is the case when sound travels in air. If the reflector is at a distance less than 17 meter, the reflected sound get mixed with original sound. So the minimum distance must be at least 17 meter. If the reflector is at a distance less than 17 meter, the reflected sound get mixed with the original sound. If there are repeated reflections at the reflecting surface, this effect is called reverberation. That is, we can hear a lot of echoes at the same time. This effect is called reverberation. Next, we are going to study the three conditions necessary to produce an echo. the minimum distance between the source of sound, that is observer, and the reflector is 17 meter. That's the first condition. Second is size of the reflector must be large compared to the wavelength of sound waves. Third one is intensity of sound should be such that the reflected sound reaches the observer's ear must be loud to be audible. That is, the intensity of sound that reaches the observer after reflection must be loud enough so that it is audible. These are the three conditions for an echo to be heard distinctly. Now let us try to do a problem. A boy hears an echo of his own voice from a distant hill after 1 second. So time t is equal to 1 second. The speed of sound wave is 350 meter per second. So here v is given as 350 meter per second. What is the distance of the hill from the boy? We know that the sound must travel a distance of d plus d, that is 2d. We have time is equal to distance by velocity. Here time is 1 second, distance is 2d, and velocity is 350. So we get d is equal to 350 goes upwards and 2 comes on the denominator, that is 175 meter. So here time is 1 second and velocity is given as 350 meter per second. We have to find the distance between the observer and the wall or the reflecting surface. Let us take the distance as d. The sound is produced by the person. It must travel a distance d towards the wall, gets reflected and comes back after reflection. So the total distance that must be travelled by the sound wave is 2d. We have time is equal to distance by velocity. Instead of distance we can write 2d and velocity 350 meter. Time is 1 second. So on calculation we get d is equal to 175 meter. Let us try to do another problem. A radar sends a signal to an aeroplane at a distance 300 kilometer away with a speed of 3 into 10 raised to 8 meter per second. After how much time is the signal recovered after reflection from the aeroplane? So here the velocity of sound is given as 3 into 10 raised to 8 meter per second. So we can write d is equal to 300 kilometer, that is 300 into 10 raised to 3 meter. Next, speed v is equal to 3 into 10 raised to 8 meter per second. We have to find the time the signal is received back. We know that radars are used to detect the signals from aeroplanes. Here we have a radar here. It reflects a sound. It produces sound which gets reflected by the aeroplane. And it comes back after reflection. If the distance between the radar and aeroplane is d, the total distance travelled by the sound wave is again 2d. So we can again take the equation. Time is equal to distance by velocity. Here distance is equal to 2d and velocity is v. So 2 into 300 into 10 raised to 3 by 3 into 10 raised to 8. Here on cancelling we get the answer as 2 into 10 raised to minus 3 second. Next, another important point is properties of ultrasonic waves. They can travel undeviated through a long distance. They are not deviated by obstacles, so they can travel undeviated through a long distance. They can be confined to a narrow beam. It can be made very small so that they can pass through a small space, or they can be made a small beam, a narrow beam. They are not easily absorbed in a medium. These are the properties of ultrasonic waves. Next, uses of echoes. Echoes are used in sound ranging. It's the first use. The second one is echo depth sounding with ultrasonic waves. These are the two uses of echoes. Now let us study this in detail. First one is sound ranging. Sound ranging is used by bats, dolphins, and fishermen who travel a long distance into sea in search of fishes. So the first one is sound produced by bats. Bats produce a sound of about 100 kilohertz, that is ultrasonic sound, when they fly. These sounds are reflected back by the obstacles. So they produce a sound of frequency about 100 kilohertz when they fly, and these sounds are reflected back by the obstacles. Using this, they can locate the obstacle and turn away from it. This process of detecting obstacle is called sound ranging. Dolphins also use this sound ranging. They also produce ultrasonic sound. They use echoes produced by this ultrasonic sound to detect their enemies and obstacles. Fishermen also use this technique, that is, they have equipments which produce ultrasonic sounds, and they are received back after reflection from a shoal of fishes using a detector. Distance of the fish d is equal to v into t by 2, where v is 1400 meter per second. This is the speed of ultrasound waves in water. So the sound of ultrasound wave is 1400 meter per second in water. Next, second use of echoes is by sonar. Sonar is sound navigation and ranging. Ships use these techniques. Here we have a ship here. They produce ultrasonic sound which is propagated in all directions. If there is an obstacle or an enemy submarine here, this sound waves strike the obstacle and gets reflected back. Again, velocity is equal to 2 into depth of obstacle by time. So here we can write 2d. V is velocity and t is time. D is equal to v into t by 2. The depth of the obstacle can be found using this method. This is called echo depth sounding. The third use of echo is in medical field. Echoes are used in ultrasound scans for imaging human organs. Echocardiography or ECG is used to obtain the image of human heart. Again, let us try to solve a problem here. On sending an ultrasonic wave from a ship towards the bottom of a sea, the time interval between sending the wave and receiving it back is 1.5 seconds. So t is 1.5 second. Velocity of sound wave in sea is 1400 meter per second. V is 1400 meter per second. Find depth of the sea. We have d is equal to Vt by 2. So on substituting, we get, instead of V, 1400 into time is 1.5 by 2. In calculating, we get d is equal to 1050 meter.